This is Trig Identities Part 12, and I'm sure you remember the Euclid proof we were trying to present to you in the last video. Well, we're going to present you something else. It has nothing to do with Euclid, but it will make this quite simple. What they're trying to do is to try to get you to establish that the cosine of negative a equals the cosine of a. Now, what is a? A is an angle. Here's angle A. Here's angle negative a. If A is 30 degrees, then A over here is going to be negative 30 degrees. If A is 45 degrees, then negative A is going to be 45 degrees. If A is 60 degrees, negative A is going to be negative 60 degrees, and so on and so forth. Okay. Now, how do we establish this? Okay. So what we're doing is, whether that angle is positive or negative, we're going to take the cosine of it, and regardless of whether it's positive or negative, it's going to have the same cosine. Okay. How do we know this? Step one, we have the Cartesian coordinate system. And if you need to look this up, you go right ahead, but if you do, pause the video, look it up, come back here. Now, the Cartesian coordinate system has 4 quadrants. Quadrant 1. 2, 3, 4. Okay? And based on whether some point lands in quadrant 1, 2, 3, or 4, you have these coordinates. Okay? Now then, this is a unit circle. Okay? And what do we say about unit circles? That the radius that comes from the center of that unit circle to its outermost edge is going to be 1 of something. The measurement is irrelevant at this point. It could be centimeters. It could be inches. It could be miles. It could be kilometers. Doesn't matter. It has to be 1 of something. That's it. Okay? Now then, if we draw this line from here to here, and we draw this line from here to here, the x-coordinate of this line is going to be exactly the same as the x-coordinate of this line right down here. So that means that the x-coordinate is going to be positive up here and positive down here. Now, what did we say about finding cosine at all? We said that cosine is the length of the adjacent side divided by the hypotenuse. That's how we find cosine. Now then, what's the adjacent side? This is the adjacent side, right here. That means it's on the x-coordinate system. Well, what's x in here? It's positive. Where's the hypotenuse? Hypotenuse is here. Hypotenuse is here. How do we find out the length of the hypotenuse? Well, we squared the adjacent side, we squared the opposite side, we added those two together, and then put that answer over here and square rooted it. Now let me do that again. By the Pythagorean theorem, which is Euclid Book 1, proposition number 47, if you find the length of this side here and square that number, so you're going to have x squared, and if you find the length of this right here, and you square that number, which is y squared, then adding x squared plus y squared is going to give you z squared. And if you square root z, that's the length of this. That's how we found out it was 1. Of course, then again, we said this was a unit circle. This is going to be 1 anyway. There you go. Now then, so the adjacent side is going to be square root of 2 over 2, whether it be up here or down here. The hypotenuse is going to be 1, regardless. So we can say that this coordinate, because it's being divided by 1, is the cosine of angle A. It also happens to be the cosine of negative angle A. Now you say, okay, we can accept all that. So when we're saying that the cosine of negative a equals the cosine of a, what we're actually saying is that if that acute angle, because this is what this is an acute angle. What's an acute angle? Well, it looks pretty, but this acute angle is less than 90 degrees. So if this less than 90-degree angle appears in quadrant 1 or quadrant 4, then the cosine of negative A equals the cosine of A. And that's how you get that. Now, I know the next thing you're going to say to me, well, okay, what if this acute angle appears in quadrant 2 or 3? We're going to get into that. But at least now you have half the proof. So, does the cosine of negative A equal the cosine of A if the angle appears in quadrant 1 or quadrant 4 of the Cartesian coordinate system if you're drawing a unit circle? The answer is yes. And now you see how. Alright. I will tell you more in a future video, so stay tuned.